right, so we are going to discuss our final lesson in our unit on inequalities, and today we're going to focus on solving absolute value inequalities. All right, and to get to that and to make some connections to what we've done with our other linear inequalities, we're going to do an opener, and we're going to connect two parts of that opener. All right, so for the opener, here's what I want you to do. All right, so I want you to do parts A to F. All right, so you're going to need some colored pencils. You're going to need a red colored pencil, a blue colored pencil, and a black pen. All right, now if you don't have red and blue, all right, just get two different colors. That'd be great. All right, and just do the graph of the absolute value in one color. Do the graph of your horizontal line here in another color. All right, answer those questions here on C and D, and then I want you to solve this absolute value equation, and then we're going to talk about how that all connects, all right, as a whole, and then how do we get that and relate that to inequality. So go ahead and pause the video, do parts A to E, turn that video back on, and we'll see how you did. All right, so let me pull my answer key up here. All right, and now you can see the work. All right, so here's really what we wanted you to see, right? Here's our red graph. All right, that's our absolute value. We have a vertex of -3, -1. We have a rate of change of 3 over 1, so up 3 to the right 1, up 3 to the right 1, and to the left there to create that. We have a horizontal line at y equals 5. All right, and then notice we drew these vertical lines through our points of intersection, and those vertical lines are at x equals -5 and x equals -1. All right, so that's part D there. Now, here's the connection. Once again, we're going to try to connect the visual and the graphical to the analytic, the equation work that we're going to do in just a moment, all right, with solving. So now, when we solve this absolute value inequality, or excuse me, equation, before we get to the inequality. When we solve this absolute value equation, all right, we subtract 5 to get it equal to 0. We do our cover-up method. What minus 6 is 6? That would be 6, so all of that has to equal to 6. All right, divide 6 by 3, so x plus 2, absolute value of x plus 3 equals 2, I should say, which means that x plus 3 could equal to 2, or, excuse me, x plus 3 could equal to -2. And if we subtract 3 here, we get x equals -1, and if we subtract 3 here, we get x equals -5. And notice, those are the exact values where those two things are equal, where those two graphs are equal. So just like we did with equations, right, we want to know, okay, those are going to be our anchors, right, where those two graphs are equal, all right, where they intersect. Those are our anchors. And notice when we're solving an absolute value, we have the possibility of getting two anchors, all right. Now, let's move on and kind of do this part together. So now let's look at, all right, so how does the solution from part E connect to the graph? I just answered that, right? That's where the x values where they're equal, much in the same manner that we talked about with our linear equations. All right, so now on part G. Now take an index card and line it up with the horizontal line so that it's below the horizontal line and covering up the bottom part of the graph. All right? And so I'm going to do that right there. Okay, so if we cover that up, right? And then where do you see the absolute value graph? All right? Is it between the vertical lines or outside the vertical lines? So basically it's saying if we look at those vertical lines, which are the black lines that we drew in there, we can see that the red graph, which is the absolute value graph, all right, we can see that that's on the outside of those vertical lines, correct? All right? Okay, so now if we go the opposite way, right, and we cover up the top part of the graph, all right, get that there to stay, all right, so now looking at F, all right, now, where do we see the absolute value graph? Is the red graph between the vertical lines or on the outside? And we can see now it's between those vertical lines, right? So now what we see is that we're going to have two different areas, right? Now, if we think about how does this relate to an inequality? If we look at what's covered here, the red graph is below the blue graph, or the red graph is less than the blue graph. So the absolute value is less than the blue graph. All right, if I reverse that real quick, right, now if I go out here, right, outside the vertical lines, right, here to the left and here to the right, we can see that the red graph is above the blue line, right, or greater than the blue line. So on these two intervals, all right, to the left of the first vertical line, the absolute value is greater than the horizontal line. And then to the right of that vertical line, we can see that the absolute value is bigger or greater than the blue line. So now hopefully you can see how that's tying back into some of the connections we've already talked about with our absolute value graphs. Okay, so now let's flip over and look at the back, and let's just keep making some connections here. Now what I went ahead and did is I just went ahead and outlined the absolute value graph in red, and our horizontal line in blue, so you can see that it's the same graph that we were doing on the front side here, but to make it a little bit easier for you to follow along with the conversation. Okay, so now, all right, so notice, all right, where is the absolute value graph greater than the horizontal line? So where's the red graph above, all right, the blue graph, right? Now, once again, if I cover this part up, right, if I cover this part of the graph up, right, we can see it's to the left of that vertical line, correct? Or less than that vertical line since I'm going to the left, right? And we said that vertical line was at -5, right? So notice we can mark that on our number line, right? So I can put an open circle and it's to the left there. All right? Now, if I go over here, right, where is it greater? Now we skip the middle. We skip the middle and we jump and it's greater to the right here. It's above that blue line to the right, okay? And we said that that vertical line is that x equals -1. So now we want everything to the right of -1, just like that. All right? And here's where we make some connections. What does that look like? All right, I'm going to give you like 10 seconds, right? If you want to pause the video or just think about it, does that look familiar with something that we've talked about already in this unit? All right. Hopefully you said it does. Hopefully you said this reminds you of those OR compound inequalities, right? All right. That looks just like those graphs of those ORs, right? It can either be less than -5 or greater than -1. All right. So you're seeing some connections, hopefully. All right. Now let's look at the next part here. Okay. So now where is this absolute value less than 5? Or where is it below 5? Where's the red graph below the blue graph? And now I'm going to cover up the top part here. All right? And now we can see it's between those vertical lines, right? All right? This is where our red graph is less than the blue graph. It's between -5 and -1. So if I put that on my number line, right, here's -5. All right, here's -1. And it's between -5 and -1. All right. Once again, give you about 5 seconds. Does this remind you of anything that we've already discussed? All right, hopefully you said, that's right, that looks like our AND compound inequalities, right? Excellent. Hopefully you saw that. All right. And so the idea is this, is that when we solve an absolute value inequality, the end result is going to look like either an OR compound inequality or an AND compound inequality. All right, that's really what we wanted to look at. Okay, so now, all right, let's just do a few more of these kind of visual examples, all right, before we get into the mechanics of solving, all right, an absolute value inequality. So now, when I look at number 1 here, all right, where is this absolute value graph greater than or equal to -2? So where is it above that line, right? Where is it above that line? So notice, here's where they're equal to. There's that point of intersection. Here's where they're equal. That's the point of intersection, right? I can draw that vertical line right there. I'm going to draw this vertical line right here. And I got 3 pieces to look at. I have to the left of the vertical line, between the vertical lines, and to the right of that vertical line. So when I look to the left out here, notice, all right, and once again, just for emphasis, all right, I'm going to highlight our red absolute value here, just like this. All right, okay, and then here's our horizontal line again. Now I'm just going to go from section to section and look at that, right? So when I look out here to the left, all right, I want the absolute value to be greater than the blue line, the red to be greater than the blue line. Is that happening out here? Nope, not true out here, so we don't want that interval, right? Now I go to the middle. There it is. The red graph is above the blue graph, right? It's greater than. So we definitely want that area. And then we go out here to the right-hand side. Once again, the red graph is below the blue graph. It is less than out here, so we don't want that interval. So now notice we're between those lines. We're in that AND situation, right? We want to be between, all right? That looks like -5 and +7. So we want to be between, all right, -5 and +7. How about that? All right, so hopefully that's making some connections. All right, let's look at number 2 here. Once again, I'm going to have our absolute value be red. So I'm just going to trace that in red real quick. All right, I'm going to trace our line here in blue to make it a little bit easier to see. All right, so now we want to know, where is this absolute value graph greater than 6? Where is it above 6, right? Where's the red graph above the blue graph? So I'm going to start by, where are they equal? Right there, correct? All right, I'm going to draw a vertical line through both those points of intersection here. And once again, we're just going to go bit by bit and analyze here. So when I look to the left, notice the red graph is above the blue graph. So the red graph is greater, so we definitely want that area, right? Let's go to the middle here. Notice the red graph is below the blue graph, so it's less than. Well, we want the absolute value to be greater than, so we don't want that area. All right, and then I'm going to come out here to the right side. Once again, the red graph is above the blue graph, so the red graph is greater than. That absolute value graph is bigger than, greater than the blue graph, so we definitely want that interval. And notice this is everything to the left of -2. So that would be x is less than -2, or we can jump over here to the right side and we can pick any value that is greater than 2. All right, so hopefully this is helping you visualize what's going to happen when we solve in just a moment, I should say. Let's do 2 more of those together, all right, before we get into some actual equations. All right, now notice on this one, we want to know, where is the absolute value graph less than 1? So our absolute value graph is our red graph here, right? And then 1 is this graph right here. All right, well, notice something. Where is our absolute value graph less than 1? Where is our red graph below the blue graph this time? And notice it's not. It's never going to be below that. That will never be true. So can you guess what that means about our solution? Hopefully you said it. That's right. So it could be no solution. Notice if it was reversed, if this had been a greater than problem, it would have been all solutions, right? Because it would always be above the blue line. So notice that when we're working with absolute value inequalities, it's possible to get no solution or all solutions. All right, and we'll talk about what that means when we solve equations in just a moment. All right, you know what? We're getting a little long on the video here, so I'm going to skip that 4th one and just get into, all right, how do we solve an absolute value inequality? So once again, it's going to be a very similar process, right? We're going to solve for our anchors, all right, just like what we did before. And we just have to remember that when we solve an absolute value, we should be expecting 2 anchors. All right, we saw those 2 points of intersections on all the prior problems there, right? We're going to mark those anchors with an open or closed circle based on our inequality symbol, just like before. Now, test a value in each section, and now there's 3 sections. And we're going to talk about a way to speed that up as we go through this process, all right, to determine where to shape. And then we're going to write our inequality, and remember that this is going to be an or or an and when we finish. Okay, so now let's look at an actual equation and do some solving here. So let's flip the page and let's look at problem number 5 here. So here's our absolute value equation. So we have the absolute value of x plus 7 is greater than 14. So once again, just like we did with equations, we're going to start by making it, or excuse me, inequalities, linear inequalities. We're going to make it an equation, and then we're going to solve that equation. All right, so I'm going to subtract 14. Subtract 14. So the absolute value of x minus 7 is equal to 0. Now I'm going to use my cover-up method. What minus 7 is 0? 7. So that means the absolute value of x could be 7. Now remember, this is where we get our 2 anchors, right? There are 2 numbers that are 7 units from 0 when we talk about absolute value. All right, so positive 7 is 7 units to the right, and negative 7 is 7 units to the left. So there are our 2 anchors, all right, that we're going to get. Now, I'm going to mark both of those with an open circle because this is a greater than problem. All right, so now we have this and we have this. All right, so now normally we would have to test all 3 areas. But here's where we're going to be smart math students, right? We know that it's either going to be an or an and. So we're going to test the middle. Because if the middle is true, all right, if the middle is true, all right, then we're going to get, all right, an and. If the middle is false, then we're going to get our or statement. Okay, so let's just make sure that we feel good about that. Now, what we always should do is once we test the middle, we should always really kind of test the other area to make sure we're not in an all solution situation. All right, and we'll talk about that a little bit more in a moment. All right, so let's test that middle. So notice we just pick a number in that middle interval, and 0's in that interval. So I'm going to plug 0 in and see what that tells me. All right, so absolute value of 0 is 0. 0 plus 7 is 7, so I get 7 is greater than 14. So notice this area is false. So the inside is false. Now, here's what I want to do. I'm just going to quickly test one value, because if it's true on the outside on one side, it's going to be true on the other side. Now, if I were testing this is false, and I test one of the outside and it's false, that means everything's going to be false. All right? Okay, so let's go ahead and just pick a value. I'm going to pick negative 10 and plug that in. And then negative 10, absolute value of negative 10 is 10, so I get 10 plus 7 is greater than 14, and I get that 7 is greater than 14, which is true. So that means this area is true, which means this area is true. So now notice if I shade that way and that way, we get that OR inequality. All right, so now that means it could be x could be less than negative 7, or x could be greater than 7. All right. So let's keep moving. Let's look at number 6 here. All right, so now, once again, the first thing we want to do is make this an equation and solve for those anchors. So we're going to have 2 plus 2 absolute value of x is equal to negative 8. I'm going to add 8 and add 8. All right, so I get 10 plus 2 times the absolute value of x is equal to 0. Cover this up. 10 plus what is 0? Negative 10. So that means 2 times the absolute value of x is equal to negative 10. And then 2 times what is negative 10? And that would be negative 5. And so notice here. All right, I get the absolute value of x is equal to a negative number. We should remember that that's not a possibility. The absolute value of a number will always be equal to a positive number because it's a distance. All right, so this gives me a minute to pause. So this means that we're going to be in one of those situations, right? Either all solutions or no solutions. All right, so I want to go back and test here. And I'm going to test 0. All right, so when I plug 0 in to test, 2 plus 2 times the absolute value of 0 is less than negative 8. Well, the absolute value of 0 is 0. 0 times 2 is 0, so that leaves me 2 is less than negative 8, which is false. So that means everything is going to be false, which means this is a no solution problem. If that had been true, then it would have been all solutions. All right, so this is just a way of making sure that we're good on all of our testing. All right, let's do one more problem together here. Let's do number 7. So once again, let's start by writing it as an equation. All right, and then solve that equation. All right, so it's already equal to 0. So what minus 8 is 0, which would be 8. So all of this must equal to 8. And then 8 times what is 8? That would be 1. So that means the absolute value of x minus 5 is equal to 1. Now remember, there are two numbers that have an absolute value of 1. So 1 has an absolute value of 1, and negative 1 has an absolute value of 1, right? And so this would be x equals 6. All right, 6 minus 5 is 1. And then this would be 4. 4 minus 5 is negative 1. So there are two anchors. We know that they're going to have a solid circle, so let's go to 4 and 6. All right, and put that solid circle on our anchors. I'll get it right here in a second. All right, so notice there's one good number to test that's in the middle of our anchors here, which is 5. So I'm going to take 5 and plug it in to my inequality and test up here. All right, actually I'm going to test right here. So we're going to have 8, and then 5 minus 5 inside our absolute values, then minus 8 is less than or equal to 0. So the absolute value here we're going to get is going to be 0. All right, because 5 minus 5 is 0. Absolute value of 0 is 0. 0 times 8 is 0. So I get 0 minus 8 is less than 0, or less than or equal to 0. So I get negative 8 is less than or equal to 0, which is true. So we definitely want that middle, right? Definitely want that middle. Now, if you want to verify this just to be good, once again, we can test one more value on the outside here. Notice 0 is on the outside. All right? Now, if this is just an and, I should get a false statement because we only want the middle on an and, right? So notice I'm just going to test 0. So I'm going to go 8 and 0 minus 5. inside my absolute value there. 0 minus 5 is negative 5. The absolute value of negative 5 is positive 5. And then 8 times 5 is 40. 40 minus 8 is 32. And so notice I get 32 is less than or equal to 0, which is false. That means this side would be false, and this side is false. So we can test again if you're unsure, just to verify which situation you're in. All right, and then we just write our inequality. So 4 and 6, less than or equal to, all right, just like that. And there you go. And that's how we solve absolute value inequalities. All right, so great work on this unit. All right, be sure to do your video check-in, and then I will see you in class next time.